In this video, what we're going to discuss is all about the exterior angle of a triangle. So, before we learned that the sum of the interior angles of the triangle is 180 degrees. So, what we're going to do now is, what if we are going to consider the exterior angle of a triangle, meaning the angle outside of the triangle, then what's the relationship of this exterior angle to the interior angles of the triangle? So here we have considered the triangle with interior angles, angle A, angle B, and angle C, and the outside angle or the exterior angle is the angle D. So what we learned before is that we have angle A plus angle B plus angle C is 180 degrees. This is because this is angle sum of the triangle. That's the principle of angle sum of a triangle. We also learned that angle C plus angle B, that's also 180 degrees. This idea is because this rule is because they are angles on a straight line. Okay, so when we add angles on a straight line, these two angles here, they add up to 180 degrees. So our equation number 1, which is angle A plus angle B plus angle C equals 180 degrees, this is because of the principle we learned before that when we add the interior angles of a triangle, it adds up to 180 degrees. The second equation, which is angle C plus angle D equals 180 degrees, it comes from the principle that when adjacent angles are on a straight line, they add up to 180 degrees. Now, since by logic, since they are both equal to 180 degrees, we can say that by transitive, we emphasized before the transitive, by transitive law, we say that this angle here, this sum here is also equal to the sum below because they are both equals to 180 degrees. So we say that angle A plus angle B plus angle C is equals to angle C plus angle D. So this one is from the first equation. This one is from the second equation. They are both equal to 180 degrees. So therefore, we can make another equation equating this sum of angles. Okay. Now look at both sides. They have both angle C. So we can remove that one, angle C. So remember, equation is just like a balance beam or a weighing scale, a balance beam. When we remove something from the left, it must be the same quantity that we must remove something from the right. So by that basic mathematical idea alone, we can remove angle C from the left side, this angle, because the equation will not be affected because we're going to remove angle C also on the right. So what we notice is that the remaining equation will become angle A plus angle B equals angle D. This one is actually the equation for exterior angle of a triangle. So if we're going to look at that in our figure, it seems like that by this derivation, it seems like that the angle D, the exterior angle, is just the sum of A and the B. In the next slide, we are going to define what does A and what does B represent with respect to angle D. So it seems that this is our equation, that this equation basically tells us that D is just the sum of A and B. So here we go. We learned in the previous slide that angle D is just the sum of angle A and angle B. So now we are going to define angle A and angle B. with respect to D. Okay? So angle A and angle B are what we call the opposite interior angles of angle B. So the relationship is that when we add the opposite interior angles, that is equal to the exterior angle. So if we're going to make that in statement, okay, the exterior angle of a triangle is equal to the sum, meaning we're going to add here sum of its, so remember the antecedent its, the pronoun its, opposite interior angles. In this context, in this illustration, that's A and B. Okay. So it is very important that when the exterior angle is located somewhere else in the triangle, we will eventually identify which are the opposite interior angles relative to that given exterior angle. So the next slide will give us some scenarios that exterior angles are located and its corresponding opposite interior angles. So as you can see on the figure 1 on the left, we have angle X being the exterior angle, A and B being its opposite interior angle. So by using this principle, by using the same idea as this, we can say that angle X is just the sum of angle A plus angle B. Let us look at this figure number 2. Angle A is the exterior, so we say that the exterior angle of a triangle is equal to the sum of its opposite interior angles, which is the X and Y here. So we say angle X plus angle Y. So that's how our equation works. And number 3 figure, it says that our exterior angle is M. So we say angle M is just the same as the sum of angle Q plus angle P, or angle P plus angle Q. The same so with figure number 4. Our exterior angle is angle P. So we say angle P is equal to the interior angles, opposite interior angles, angle A plus angle B. So let us recap. What we showed here is that when the exterior angle of a triangle is located somewhere else in the part of a triangle, we should be able to locate which are its opposite interior angles. So I hope that this 4 figures somehow gives us an idea of the relationship of the exterior angle and its opposite interior angles and their different locations in a triangle. So next is what we're going to do is we're going to apply these equations in solving unknown quantities. So in example number 1, the exterior angle is x degrees and the opposite interior angles are 45 and 50 degrees. So we say, using our principle a while ago, that the exterior angle is just equal to the sum of its opposite interior angle. So we have 95 degrees. So x is 95. So here we have A being the unknown, 20 is one of the opposite interior, 45 degrees is our exterior angle. So we say the exterior angle is just the sum of the two opposite interior angles. So subtracting 20 both sides. So this is, let us emphasize first this equation. These are the opposite interior angles. This is the exterior angle. So we are simply following this principle. Okay. So from here, we can solve the value for the value of a by subtracting both sides by 20 degrees. Subtracting both sides by 20 degrees. That gives us a degrees is just 25 degrees. That gives us a being just 25. Next. Here, so it is important in a figure we can spot directly which one is the exterior angle and which are its opposite interior angles. So here our exterior angle is 5x degrees and the inside two angles are its opposite interior angles. So what we say is that the exterior angle, so put the principle in mind, the exterior angle 5x degrees is equal to the sum of the interior opposite interior angle. So if we're going to add it, we have 100 degrees and 5x times 100 degrees, so imagining 5 times something, that gives you 100, so that is 20. So, or we can simply say, we can divide both sides by 5, we have x degrees equals 20 degrees, or simply x is just 20. Okay. In the fourth example, we have the exterior angle is 50 degrees and the interior angle, opposite interior angles are 20 degrees and 6y degrees. We are going to solve for 6y. So we say that using the same principle, we have 50 degrees is just equal to 6y degrees plus 20 degrees. Subtracting both sides by 20. So we have 30 degrees equals 6y. Dividing both sides by 6y, or simply use the idea that 6 times y equals 30. 6 times something, that gives us 30. So what's that something that we need to multiply to 6 to give us 30? And that is 5. 5 times 6. Therefore, we say y is 5. Or simply we follow the algorithm of division, dividing both sides by 6. Dividing both sides by 6. Y is just 5 degrees, or simply y is 5. Okay. The next example is a little bit complicated, number 5. So we are going to look for what is the value of A and what is the value of B. Okay. So as you can see, A is like the exterior angle of 45 and 61. This is the importance of how can you make relationship, how can you spot first the exterior angle and its opposite interior angles, because when you can spot that, you can make your equation and eventually you can solve the equation. So as you can see here, we have A degrees, it's an exterior angle relative to 45 and 61. So if we're going to redraw the triangle, or let us say erase some part of the triangle, and look at that. So this one is actually an exterior angle. So we say that A degrees is 45 plus 61. So we have A degrees is simply 106 degrees, or simply A is just 106. That's an obtuse angle. So we already solved for A. How about B? Notice that B is also an exterior angle. We can use 15. So supposedly let's try to erase this part of the figure. As you can see, 2B is an exterior angle, and we can make an equation of that using the 15 and the A. Okay? Because that's an exterior of A and 15. 2B is the exterior angle relative to 15 and A, because this one is also a triangle. So from that, we can say that the exterior angle 2b, the exterior angle 2b degrees, this one, is just equals to the a degrees plus 15 degrees. Remember that this equation has two unknowns, b and a. We should observe first that a is already solved in the first solution. So by that we can replace a with 106. So instead of saying angle A, we can say 2b degrees equals 106 degrees plus 15 degrees. So that gives us 2b degrees equals 121 degrees divided by 2 divided by 2. B degrees is simply 60.5 degrees, or simply B is just 60.5 or 60 and 1/2. Okay, 60 and 1/2. Next, in this figure, what we are tasked to solve for x. As you can see, we can relate x if we have measures on this part, because the blue mark angle ACD is an exterior angle. If you're going to erase this line, so the angle C part, which are ACD, angle ACD, which are marked blue, is actually an exterior angle, and we can make an equation of that using the x degrees and the 21 degrees. Okay, so that we can solve for x. However, we do not have a measure of that blue angle there. And there is another important information that we have to observe. This one, triangle ACD is isosceles. Angle ACD is an isosceles triangle. What does it mean? When an isosceles triangle, the definition of isosceles triangle is that two sides are equal. Look at here. AC is equals to AD. So meaning their opposite angles of AC and AD are also equal. Meaning this are equal. And if we find the measure of this angle, we can use that to make an equation of x and 21. So let's solve first the angle ACD. Okay, angle ACD. So as you can see, so angle ACD plus angle, the other one, ABC, plus 40 degrees. This add up to 180 degrees. These three angles are angles of a triangle. This angle, this angle, this angle are all angles of are all interior angles of a triangle. So we can solve using the angle sum of a triangle. So we say angle sum of each triangle. That's the rule that we use. So subtracting 40 both sides, subtracting 40 both sides, in the right side as well. So we have angle ACD plus angle ADC is simply 140 degrees. Now here comes the importance of the equality of these two angles. We said a while ago that triangle ACD is an isosceles, meaning AC is equals to AD. What's the implication if the two sides are equal? Their opposite angles are also equal. So meaning ACD and ADC are equal. So it's like they are just sharing the 140. So if ACD and ADC are equal, and both of them are, when you add them both, they are 140 degrees. Since they are equal, meaning they're just sharing this 140 into two equal parts. So therefore, we say that ACD is 140 degrees shared by 2, that is 70 degrees. So we learn now that ACD, angle ACD, is 70 degrees. So this one is 70, and this one is also 70. So now we can now form an equation of x, the 70, the x, and the 21 using the exterior angle of a triangle. So let's do that. So what's the exterior angle? 70 degrees. What are the opposite interior angles? X and 21. So we say the exterior angle is 70. The exterior angle is 70. And the opposite interior angles are X and 21. So that can be seen in the figure. So from there, we can solve for X. So 70 minus 21 is 49. So X is simply 49. So from there, yeah. So this problem is there's a lot of concepts involved. The first concept that we use is we solve angle ACD using angle sum of a triangle. And within that, we also know that ACD is an isosceles triangle. So if we do not know the definition of isosceles triangle, it will be hard for us. So from that, we were able to solve angle ACD as 70 degrees. And that is actually an exterior angle. And its opposite interior angles are the 21 degrees and the X degrees. And we can use the three quantities marked in yellow to set up an equation using the exterior angle of a triangle. Next, here what we're looking for is angle BDC, this angle. What's the measure of this angle? And we have another information that this one is in 90 degrees. You have to take note of that. Okay. So as you notice, BDC is actually an exterior angle, and we can relate it to this angle and to that angle. So from that, we say angle BDC is simply 46 degrees plus, what's this angle? This part here, this angle, that is angle ABD. Okay, that's angle ABD. The problem now is we don't have the measure for angle ABD. Okay, we don't have the measure for angle ABD. So what we're going to do? Let's find angle ABD. Remember that angle ABC is 90 degrees and this is already 34 degrees. So you see the logic there? This is a total of 90 degrees and there's already a part that is 34. Therefore, the remaining measure, that's the angle ABD. So we say that angle ABD was 90 degrees minus 34 degrees. Okay? So what's that? 90 minus 34 is 56 degrees. Okay? So this 56 degrees, we can replace that here so that we can solve for angle BDC, which is our exterior angle. So we say that 40 degrees plus angle ABD is 56 degrees. Yeah, therefore angle BDC, the one that is obtuse there, this one, is actually the sum of 46 and 56, and that is 102 degrees. So that is angle BDC. So it's kind of a little bit hard, but not that hard, because informations are already kind of discussed before. Last figure. Let's try to solve first the 2x degrees. Okay. So which equations that we can form with the 2x? Remember, 2x is an exterior angle, and that's the exterior angle. So we say 2x degrees. And its opposite interior angles are this. Look at this. If you're going to remove this part, okay. So this one, we need this one. Sorry. we need this one, and we need this angle. Okay, because those are the 60 degrees, and that angle there, the missing angle, those are the interior angles, opposite interior angles, that we're going to use to make an equation for 2x degrees. So however, we do not have this measure, but we know that that is also 50 degrees because of vertically opposite angles. We know that before that, when two lines are intersecting, they form vertical angles which are equal. Remember that. That's the second lesson in our geometry. Okay, so therefore this is also 50 degrees. So we say that 2x degrees is 60 degrees plus the 50 degrees. Okay, remember this principle here, that is vertical angles. So from that, we can solve for for x. We have 110 degrees. Therefore, x divided by 2x is 55. Okay, x is 55. Now, how about the y? How about the y? Look at the y. This 5y here and the 30y are also opposite interior angles relative to this 50 degrees. So as you can see, the figure looks like this. If you're going to redraw like that, this is the 50 degrees, this is the 30 degrees, and this is the 5y degrees. So we can set up also our equation using that. So we say 50 degrees, the exterior angle, is equals to 30 degrees plus 5y degrees. Okay, exterior angle of a triangle. So subtract 30 degrees, so we say 20 degrees equals 5y degrees. Dividing both sides, 5 times something, that gives us 20. That is simply y equals 4. So that is our that's the kind of a little bit advanced, not really that advanced, intermediate problem using exterior angle of a triangle. That's all.